Hi all, and welcome to today's set of lectures. So this week we're introducing Android. And again, if you look on tutors there, you can see we have kind of broken down into four or five different sections. So today I want to talk, and this one I want to talk a little bit about the background and history. It's quite short, but relevant. Okay. So if we initially look at the Android origins and where it came from, so just hide myself there now for you. So in October 2003, Android Inc. Was founded in Palo Alto by this guy called Andy Rubin, and funnily enough, he actually worked with Apple. Okay, and back around '89, I think the stats would tell us that his co-workers had nicknamed him Android because of his love of robots, and again, that's where the company name came from. In August 2005, Google acquires Android Inc. It was an undisclosed fee, but they reckon it was around $50 million. It's a nice amount of money. In November 2007, we have the Open Handset Alliance being established. And again, I'll talk about that now in the next few slides. And then in October 22nd, 2008, the first Android phone is launched by HTC. Depending on where it was, if it was in America, I think it was the HTC Dream, and then in India, Mobile G1. And that was all in response to the first iPhone being launched, which was June 29th, 2007. So again, only a couple of months after the first iPhone was released, the Open Handset Alliance is established, which I'll talk about in a minute. Just one other kind of fact to note: they reckon what Android is worth around now, 2020 figures, about $2.5 billion. Okay, so that's quite a large amount of money compared to what they paid for it back only 10, 15 years earlier. And the logo itself, the Android logo, was actually developed by an employee called Arana Block, and she was only told go off and just come up with some logo, some icon, graphic that looks something like a robot. So she got her inspiration from bathroom signs. So that's where the logo actually comes from. Okay, so just to talk a little bit about the platform itself and the Open Handset Alliance. So Android is a comprehensive open source platform designed for mobile devices, and the fact that it's open source is very important, and we will refer to this again in later sections. Okay, it is championed by Google and owned by the Open Handset Alliance, which is a group of 80 plus companies, which I'll look at a graphic now on the next slide. But the goal of the alliance is to accelerate innovation in mobile and offer consumers a richer, less expensive and better mobile experience. Okay, so that was all in response to Apple releasing that iPhone in 07. So literally a couple of months later, November 07, this alliance is formed to try and, I won't say combat, but just, as I said, accelerate innovation in mobile and offer consumers a richer, less expensive, I think that was the big one there, less expensive and a better mobile experience. Okay, so to look at some of the companies, and again, you should be familiar with some of these, just highlight them for you there now. So if we look at our mobile operators, again, this primarily will be all American companies, but there's obviously some Chinese companies in there as well. Okay, so we have there's our Vodafone, we have our T-Mobile, there's China Mobile. Okay, maybe you heard of someone. There's Sprint as well. Okay, in terms of the software companies, we have obviously Google. There's some other big players there, eBay. In terms of commercialization companies, again, because it's kind of American, I wouldn't have heard of most of these myself, but maybe you have. But definitely in the semiconductor companies category there and the handset manufacturers, these are quite common, quite popular brands there. So you can look at your ARM, your Intel for your processors, your semiconductors there. We have even look at NVIDIA there. Okay. And then if we look at our handset manufacturers, good chance if any of you have an Android phone, chances are it's been created by, and the brand is one of these manufacturers. So look, we have our Garmin, the main one there, probably there, Samsung. We've also got our HTC, our Huawei, again. Look, Motorola, Toshiba, there's Sony, and then ones we may be more familiar with laptops, Acer and Asus, but they are part of this alliance as well. Again, all in response to Apple releasing that iPhone only 2-3 months earlier. Okay, so just to talk a little bit about the background. Okay, again, we will go into this in a lot more detail in later sections, but just to kind of just to touch on it at the moment, again, it's mainly very just a brief introduction. Okay, so Android, along with iOS, has and continues to revolutionize the mobile space. Okay, unlike iOS, however, and this is very important, Android is an open platform that separates the hardware from the software that runs on it. So again, we can have this one version of Android, but it can run on many different types and different manufactured devices. So, and again, that's where the alliance comes from. You have your HTC, your Sonys, your Samsungs, Huawei's, all different companies, all different physical devices, but all running more or less the same software. Whereas, as we said with iOS, it's the one device, it's your iPhone, all wrapped up, all bundled up in the one device, that main component. So you can't separate out the hardware from the software with Apple. You can with Android. Okay. Now, the positive there is this allows for a much larger number of devices to run the same applications and creates a much richer ecosystem for developers and consumers. As you can see there, we have our Android Auto, our TV, our tablets and phones, it's our Android Wear. It's even in our fridges now, our Android Things. Okay, but saying that, that's great for the consumer, right? From our perspective, the developer's perspective, it's a bit of a double-edged sword. So if you think about it, if there's a lot more types of devices that the operating system runs on, that means the developers of the apps that run on those devices have to do a lot more testing, because you more often than not, you can't be 100% guaranteed that an app that runs on a certain version on a certain device of Android will run on a different version, a different manufactured device. But Google do have things in place. There's a compatibility test suite that they can use to kind of limit those issues. Okay, but again, just something to be aware of. Okay, just another point there. It's designed for mobile devices. Okay, so when designing Android, the team looked at which mobile device constraints were likely not going to change for the foreseeable future. So a lot of these you could probably spot yourselves. Look, a couple of the main ones there: battery power and battery performance is probably not going to get massively better anytime soon. Again, you can see it there. If you can get more than a day out of your battery, you're doing very well. Okay, so a lot of the manufacturers would kind of promote the device to say it has this really, really good long-lasting battery and all the rest of it. But again, from a developer's point of view, that's something you have to be aware of and consider when you're developing your apps. Simple example: if you are building in some kind of GPS or some kind of location awareness into your app, okay, that every time you check for your location and you display that location on a map and move that location around on a map, that's going to use up a little bit of battery. So you have to decide, do I want to give real-time location updates, which will possibly drain the battery more than if I only give them a location every minute, every 2 minutes or whatever. So again, things you have to consider. Also, in general, the small size of mobile devices means that they will always be limited in terms of memory and speed. Again, it is improving, right? Those initial devices would have had at most maybe half a gig of 500 megs, then up to a gig. You can get devices now that have 4 gigs of memory, okay? But if you compare that to your PCs, your laptops, right, there is no comparison. It's a massive difference. So again, they are things you just need to be aware of, okay? On the flip side, a device's screen size, resolution, chipset may vary considerably. So you have your kind of low-end devices with kind of standard screens, and your high-end tablets with very high resolution screens. So these are things you just need to be aware of. And all these constraints have been taken into consideration throughout the platform. Okay. What I'll talk about next will be all the different versions of Android. Okay. So that'll be in the next little section. So until then, just some of the references there. We'll see those references on each section. So these kind of cover all the different sets of slides that we'll be covering in our introduction to Android. Okay, but other than that, thanks for listening, and we'll talk to you soon. Hi all. So welcome back to the second section in our introduction to Android. And this one here, I want to talk about some of the different versions of Android and then some facts and figures about Android itself and kind of the latest versions of Android, okay? So if we take a look at our versions first, okay, and again, if you remember from the previous section, we're actually going back to 2008 when it all started, okay? So if we look at our, hang on, just hide myself again for you now. So if we look at the first version there, and now the dates here are what are kind of important and just kind of important to make a note of, okay? As we'll see in a minute from the developer's perspective, okay? So in 2009, we have Android 1.5, right, called Cupcake coming out, okay? We then have, which is 5 months later, version 6, and again I'm just making a note of the API level as well. From a developer's perspective, the API level is as if not more important than the actual version of Android. From the user's point of view, the version is nice. From a developer's point of view, it's the API level, and we will keep coming back to that, okay? But getting back to this, there we have Android 1.6, a donut on September 15th, which is 5 months later, okay? 1 month later, we get Android 2. October 23rd, 2009. Now the point I'm trying to make here, and if we go on to the next one there, May 20th, 2010, we have Android 2.2, which is API level 8 coming out. So that was 4 in 1 year to start. That is tough on the beta developers, as they say, okay? So developers had just kind of gotten around to building apps in one version, and then a new version comes out, okay? Thankfully, that has slowed down, okay? So if you look at the next version, they are 4.4, we jump up to 4.4. That was October 31st, 2013, and then an API level of 19. And then roughly a year ago, we had our back in 2019, should I say, we had on September 3rd, we had Android 10, which is API level 29, okay? Saying that, that's still 15 versions in 11 years, okay? Now, thankfully, they have slowed down to roughly 1 a year. So we can see there we have the latest version at the moment, and which is Android 11, which came out there on September 8th, 2020, and is going to be API level 30, okay? So roughly 1 year going forward. One important point to note there is, for the first time ever, they're not using with Android 10, should I say, they didn't use a sweet treat or some kind of a dessert, okay? Mainly because, like with Apple, not to trying to go in line with Apple and iOS versions, but a number is a lot more universal than some kind of a treat, okay? A simple example, Kit Kat, their 4.4, were supposed to be key lime pie. But again, would key lime pie be as universally known as Kit Kat? Who knows? The decision was anyway to go with Kit Kat. So to make things even easier again, since Android 10, it's been numbered. So it'll be 11, 12, and who knows where it'll end up. Okay. So if you want to get some more information on Android 11 itself, you can go on to the developer docs there, the different versions, right? But to look at some of the timeline and the milestones, and again, this is kind of relevant. Just come back to you there now. This is relevant for developers. So you can see there that we had developer previews back in February, and then March, April. Then we have our beta releases May and June, and then the final release is actually Q3. So from a developer's point of view, the earlier that you can get using what will be the new version of Android, the longer you have to start testing your apps to make sure that they are compatible with the latest version, okay? In terms of some of the highlights of Android 11 and what's kind of new in them, okay? What's new in this particular version, okay? So again, the release date, September 8th. First beta was back in June, so again, developers could straight away start working with a version of Android, that Android 11, that was going to be very close to the final release, okay? Some of the highlights there, as I say, we have our seamless updates through this virtual AB. Now, basically what that boils down to, behind the scenes, the hard disk in the device is actually partitioned into two virtual spaces, A and B. So it can kind of update on one while you're still using the other, and that's why those updates can actually happen a lot quicker. So this allows for much quicker OS updates from your OEMs using less space. So going forward, this virtual AB would be the only supported OTA mechanism within Android. Okay, some of the features on the phone itself there. We have our Bubbles, a new messaging app, and Conversations, so making the communication parts of your phone more accessible. This notion of screen recording, which has a much better and much fancier UI, and a whole new media playback widget to manage all your media on the device. There's also dark mode scheduling and single time app permissions. Permissions have become a big issue in the last couple of versions. So if you've noticed, if you have older versions, when you allow permissions to a certain app, in older versions, that was, you gave the permissions indefinitely, and that may be not what you want, and then you'd have to go in yourself and manually turn off the permissions and all the rest of it. So what they have now is this notion of single time app permissions. So if you want to, you can just ensure that only when the app is in use and is that single time kind of just giving and allowing permissions, okay, which again all tied to security behind the phone and all the rest of it. Okay, now again, this is more relevant from the developer's point of view, so we're just going to talk about the API level and how that relates to versions as well. Okay, so the Android version number itself partly tells the story of the software platform's major and minor releases. Just hiding myself there again. So what is more important, right, is the API level. Now, appreciate these figures are a little bit out of date. I'll just show you there. Back in May 2019. But the reason being is that Google have actually stopped updating their site. Okay, and the only way you can actually get to see what the figures are and the API levels and then the percentages is actually through Android Studio, which again I'll show you some screenshots on how to find that later on. But just getting back to this point ourselves, the API level will determine which devices can and cannot run your application. So this is very important from a developer's point of view, because if you are developing apps in version 8 or 9, okay, and if that's your minimum target version, that means that your app cannot run on any device running a version of Android lower than 8 or 9. So that's why these figures are very important when you decide what minimum SDK you want to target. And there's a kind of a trade-off that there's certain features like your fingerprint and your retina recognition, all the rest of it, that will only be in the later versions of Android. So if you want to target the later versions and access all the latest features, you may be sacrificing a percentage amount of where your device or your app and the number of devices your app can be installed on. And that's why, again, these figures are important. So we'll just kind of break it down now for you over the next couple of slides. So if we look at it here, for argument's sake, if we break it down over 6, 7, 8, okay, that which be marshmallow, nougat and Oreo, that would come to about 64%. So if you targeted 6, now again, these aren't 2019 figures, I'll show you more relevant figures through Android Studio in a minute, but just to make the point, if you targeted your version as the minimum target version as 6, you would be able to, and your app would be able to be installed on around 64% of the devices out there. All right, but if you just go back to the previous slide again, if you decided to choose 8, see, I just highlighted for you there now on its own, 8 and 8.1, you're reducing that down to our 28%. So again, these are decisions as a developer you need to be able to make, and just be aware of these particular figures. Okay, now tied to that is this notion of adoption rates. Okay, so just to talk a little bit about that and how it compares to Apple and iOS. So Android adoption traditionally lags behind Apple because Apple can make its latest iOS available for all users at once, and this is the important bit, because it makes all the hardware and the software. It's all bundled up into one. For anyone who has an iPhone out there, whenever there's a new iOS released, you start getting notifications to say it's available, you can download it now, and after a certain amount of time it tells you it's going to be automatically installed whether you like it or not, right? So you kind of have no choice in the matter. So obviously iOS is going to have higher adoption rates. Okay, so
to kind of put it on, to look at from Android's perspective, and again, this is important as a developer, Android, on the other hand, is much more fragmented. Because Google lets many different hardware makers use its Android software, it can't control when all phones update to the latest software. So if you have your Samsung, or if you have HTC or Sony, whoever, you won't be getting the latest version of Android. And you would get it. You wouldn't get it at the same time that someone with a Google phone might get it, because when Google release their the latest version of Android, they will release it on certain devices. Okay, generally their own phone, the Google phone. So if you have a Samsung or if you have a HTC, you're going to have to wait, because it's down to the manufacturers themselves to roll out that update for you. It's nothing to do with Google. Okay. Now, smartphone manufacturers often add their own modifications to Android, which means that the update needs to be approved by each individual carrier first, again, slowing down the whole process. So this means that depending on which phone you own, it could take a while to receive the latest software update. So if we look at some comparison stats, right, this is in June 2020. So if we look at Android 8, 9 and 10 put together, so if you're a developer, if you were to target 8 as the minimum SDK, you'd be able to hit just nearly 61% of devices. But if you decided to choose Android 10 as your minimum SDK, you're only going to be able to access or have your app installed on 8.2% of devices, which is quite small. Okay, and that was nearly a year after Android 10 was released. If you can remember, it was September 3rd 2019 that Android 10 was released. June 2020, there's still only just over 8% of Android devices out there actually running Android 10. So again, these are facts and figures that you need to be aware of when you decide to go and build your app and decide what minimum SDK you want to target. Okay, some comparisons there with iOS 13. If you can look at there, we have 92% adoption for on the iPhone, and then across all devices using iOS, that's in your tablets as well, 81%. They are massive numbers, but that is all because of the fact that Apple produce and the device they manufacture the software, build the software and the hardware as well, which you can't say the same for Android. Okay, now saying that, it's not all doom and gloom. Okay, Android 10 has been the most quickly adopted Android update ever, so that's a good thing for Android developers and users as well, obviously. Okay, so that was that graph there was for August 2020. Okay, so to kind of explain why that is the case. Okay, it goes down to this accelerating Android updates, and this is because of three main factors. Okay, two separate kind of projects, Project Treble and Project Mainline. And in this notion of GSIs, and I just have a little snippets on all three of them there. So Project Treble specifically allows for phone manufacturers to deliver updates without having to worry about deeper hardware drivers, which trimming down how much time it takes to design and build software updates for a new device. So it's kind of separating this very close connection between the hardware and the software. So you can go ahead and start pushing out these updates without having to worry too much about the drivers behind it. Okay, so that's what that Project Treble is all about. And coupled with it is this Project Mainline. Again, similarly decouples core OS services like all your media codecs and other little tidbits into modules that can be easily updated through the Play Store. So again, you can have that pushed out automatically through the Play Store. So even as a user, you could actually go and find it yourself and not have to wait for that to be pushed out by the manufacturer. Okay, so while that doesn't directly make the process of building Android versions updates easier, it means being left on an older version matters less and less as time goes on, which is all good news for you as a developer. So you can look at targeting the later versions of Android to get the latest features and not have to worry so much about backward compatibility and the fact that there could be a large percentage of users on older versions of Android, older devices. Okay, and the last one there, are GSIs, or generic system images. This is a very nice one. This provides so the AOSP is an Android open source project that if you were to log on to aosp.com, you can actually pull down generic versions, generic system images of Android. So that's where this is coming from, that you can actually pull in a version of Android which is going to be very, very close to what will actually end up on the devices. So you can do your testing. The manufacturers can do the testing through that OEM developer preview program. So all that coupled together hopes to make a dent in that the uptake and quicker adoption of the latest version of Android. Now, saying that, right, the Android problems with fragmentation, that's what we're talking about here, that will never go away as long as OEMs outside Google exist and Android remains open source. So once you have all these companies like Samsung and HTC and Sony and Huawei and all the rest of them, once they're doing their own and building their own devices and coming up with their own version of Android, so like I said, you get the kind of generic version from the AOSP, and then coupled with the carrier, so Vodafone might add in there a little bit. You might have this, it could be a Samsung Vodafone phone, so you're going to have Samsung stock apps, you're going to have Vodafone stock apps on it, all kind of adds to that fragmentation issue. So that's never going away, right? But the practical impact of that fragmentation is less significant and less severe with each passing day because of these projects and because of all these initiatives that Google are putting in place to try and improve those adoption rates as compared to Apple on iOS. Okay, so you might be asking yourselves, why are all these facts and figures important, right? Why am I giving you these particular stats? Well, this is the reason. Okay, apps, you can see it there, apps can't succeed without downloads, right? It might sound simple, right? You could have the best app on the planet, but if nobody is downloading it, right, and this is the important bit, and this is why I'm talking about the API levels and the versions of Android, or can't download it, doesn't know about it, you won't make a cent. So what I mean there is, if you target Android 10 as your minimum SDK, okay, anyone who goes onto the Play Store that doesn't have Android 10 installed won't even see any apps that the minimum target is Android 10. So they might, you could have the best app in the world, it could be a fantastic app, but if it's not available to the users and they can't download it, it's not compatible with their particular device, they can't download it, you can't make any money off it, right? So as a developer, you need to research and take some time to think about your minimum SDK and choosing the right one for your app. Now, in this particular module, we would be probably working with Android 10, Android 11, or whatever the latest version happens to be at the time, because it's all prototyping that we're doing. We're building apps to satisfy assignment requirements and all the rest of it. But I'm just making the point that if you do have a great idea and you want to try and make money off it, you need to consider the version of Android that you're going to target. Okay. Now, just looking at choosing that minimum SDK, this is what I was talking about previously. Okay, so I'll talk about this in another section later on and kind of getting started with our using Android Studio. Okay, but this is a screenshot when we would go, one of the screenshots that we would go and create our first app with. Okay, so don't worry too much about the details at the moment. What I'm more concerned about is this here, right? Is the minimum SDK, and there's an option there to say help me choose. So if you can see it there, and again I just checked this morning as well. Okay, so you can see that if we chose the minimum SDK as 10, that was the example I was giving, it's still only 8.2% of devices. So even though I showed you stats there from back in June, this is now where we are now, right? And it's still only 8.2 in terms of the number of devices out there running Android 10. Okay, you can, if you want it, you can click on that help me choose, and what you get is something like the following. So you can see there telling us Android 10, its API level of 29, which is 8.2. But if you wanted to go back to Marshmallow and 6, you'd be hitting nearly 85%. So if you were to set the minimum SDK as 6, okay, or sorry, the minimum API is 23 and the minimum version is 6, your app would be able to be installed on nearly 85% of devices. But don't forget, that's an older version of Android. The device that it's running on may not support some of the features that you want to implement in your app. So again, you need to do your research and check to see what extra code you might need to add in, what extra alternative features you might have to add in to be able to manage that app getting installed. Okay, now just want to go through some interesting graphics, okay, that kind of compare Android and iOS. Okay, so if we look at this one here again, this is only back in August, and again check the stats this morning, and there's a very small little percentage difference, but this is the actual operating system market share worldwide. Android is actually ahead of Windows, not by much, but it's ahead of Windows in terms of the operating systems been used globally, which is would be unheard of and wouldn't even been considered, say, 10 years ago, where Windows would have been kind of the massive player in the market. Okay, if we just compare the mobile and tablet operating systems, okay, so we just compare Android versus iOS. Okay, you can see there, Android is on nearly 73% of devices out there. Okay, so even, and again, we'll see the slightly contrasting issues when we look at money and the money that Apple makes, but in terms of market share, Android is way ahead of Apple in that respect. Okay, if we look at the revenue now, this is where the comparison kind of changes. The App Store has the higher kind of revenue. Okay, so you can see it there. The Google Play Store, look, in first quarter there, first half of 2018, 11.8 billion. The App Store 22 jumped up massively the following quarter. If we look at compared to even 2020 figures, all right, again, we have COVID, as I call it there, the COVID effect on app revenue. So a lot more people downloading apps. Mobile app spend there rose by over 23% during the first half of 2020. So, like, if you look at the figures there, billions and billions of dollars been spent on apps and games. Okay, so again, games, game development is still a massive revenue stream. Okay, if we look at, again, talking about games, and look at apps, in particular games download, just highlight the figure there, 71.5 billion first time app installs, right, which was a 26.1 rise from the previous year. Again, a lot of it down to the COVID effect. But if you again look at the comparisons here, the Play Store, Google, is way ahead of Apple. Okay, so if you just go back to our money wise, Apple is leading the way. If we look at downloads, obviously because the bigger market share, the bigger Play Store itself, which I'll talk about again later on, Google Play is ahead on that front. Okay, now the last couple of graphics here I thought were very interesting. Okay, so if we look at this one here, right, this is what happens in an internet minute. Okay, so this was 2019. So just to highlight some of those figures for you there, right? Look, if we look at Netflix there, like, look, nearly 700,000 hours watched. This was very, very interesting for me. Nearly $1 billion spent online. Sorry, $1 million spent online. Okay, here we have our messages. Look, 41.6 million messages sent, and again, look, Facebook and WhatsApp, grouping those together, kind of, it's the same company. If we have a look at our tweets, okay, on Twitter there, Instagram, right, nearly 347,000. Look at our app download. This is in a single minute, 60 seconds. So the time I'm talking to you now on this particular slide, that's the number of downloads roughly we've had. Okay, and then if we look at our text there, look, 18.1. But if we compare that to 2020, right, massive difference. And if you even look at your Twitter, just highlight there for you again. If we look at Twitter and Instagram, okay, look at those figures, massive jumps, nearly doubled Instagram and tweeting. So it seems to be the kind of current trends at the moment. And again, even if you look at your spend, 1.1 million spend, 764,000 hours on Netflix. Okay, but that's what kind of caught my eye. Our Instagram and tweeting more than doubled. Okay, and even if you have down here, I know it's kind of been in the news as well, Look at our TikTok, 1,400 downloads on TikTok within 60 seconds. Okay, and again, look at our messaging. Again, 59 million. So big increases there again. Okay. So I suppose the point we're making there is that mobile devices probably aren't going away anytime soon, right? They're going to be around for a while. And of the billions of people on this planet, right, eventually everyone who can afford one will probably have one, right? But all those benefits, they come at an ethical and environmental cost, okay? So that's what the next section kind of looks at. It's a small section, but I thought it was very interesting, very different spin on smartphone devices and that whole area. Okay, so and it's the Android Fairphone. Okay, so that's what I'm going to look at next. Okay, so going to just the same references there again. Okay, and thanks for listening, and I will talk to you in the next section. Okay, bye bye. Hello everyone, and today I want to talk to you about the Android anatomy, and we'll focus on some of the key features of the platform and some of the components as well. Okay, so the agenda for today will be a quick cover of and a quick look at the platform fundamentals. We'll look at the Android application components, and then we'll have a look at the Android lifecycle, which is quite important also. Which so for developing our Android apps, whether they're very simple ones or very very complex ones, we still need to know about the Android lifecycle and what kind of methods, functions are there that we can use and leverage within our app. Okay, so to begin with, to have a quick look at the platform fundamentals. Android is an open source Linux-based software stack created for a wide array of devices and form factors, all different kinds of devices, different sizes of devices. So if we have a quick look at the different kind of layers that are within it. Okay, so we have our system apps layers at the top. We will have the Java API framework. So it's generally you as a developer will be working through or with these two layers mainly. Okay, it's worth knowing about these layers, so the native libraries and the ART or Android runtime and some of the core libraries, and then we're getting closer to the kind of hardware side of stuff there. So we've got our hardware, our abstraction layer, HAL, and we've got a Linux kernel as well there. So this is for all your device drivers and all the rest of it. So we'll talk a little bit about each, and then where necessary we kind of just focus on what's more specific to us as developers. Okay, so to begin with, if we have a look at the Linux kernel, so we kind of start from the bottom up. This is the foundation of the Android platform. Allows Android to take advantage of key security features and allows device manufacturers to develop hardware drivers for a well-known kernel. So the likes of your Sony, likes of your Samsung, HTC, Huawei, they are all developing drivers for this particular kernel, so that obviously keeping costs down as well. Okay, which this is very different to kind of the iOS world, where it's all built into the hardware and the software are all in the one device. Whereas in Android, and that's why so many different manufacturers can actually build this stuff. We would have talked about this in previous sections as well, but it's because Android is based on this open source software stack that you, even as a developer, if you want, can kind of swap in and swap out individual kind of components and elements of the layer. Okay, so that's the first one, the Linux kernel. Second one there, hardware abstraction layer, or HAL for short. So standard interfaces that expose device hardware capabilities to the higher level Java API framework. Multiple modules, each implementing an interface for a specific type of hardware component. And then the modules are loaded on demand. So if you can see it there, again, we would have our kind of our audio, our Bluetooth, our camera, the different sensors, the Wi-Fi stuff will be in there as well. Your network provider, whoever you're kind of you're dealing with for your service, would all kind of would be kind of built into that particular layer. Again, developers don't really need to know too much about that, but it's worth knowing or worth being aware that the layer is there. Especially if you're kind of you might have debugging your application, and kind of these hardware errors might pop up, that at least you might have a place where to start to try and debug that issue. Okay. We then have our Android runtime, or ART for short. So each app runs in its own process and with its own instance of the ART, the Android runtime. Okay, executes DEX files. This is short for Dalvik executable format. It's like your basically the format. It's like your .exe with programs, or a .app on a .exe on Windows machines, and kind of a .app application on kind of iOS machines. Okay, DEX is a bytecode format designed and optimized for minimal memory footprint. Just other points to note as well over here. Excuse me, the runtime itself converts DEX files to more compact machine code via ahead of time AOT or just in time compilation, has optimized garbage collection, and has debugging support, profiler, diagnostic, and crash reporting. So I suppose, again, from our point of view, developers' point of view, we don't need to know too much about this, but it is worth being aware that this is what when our users would download your app from the Play Store. This is what gets compiled at just in time and ahead of time. So in the latest version with Android runtime, it's compiled. It's partially compiled when it's available on the Play Store, and when it's actually downloaded, then it's that ahead of time and just in time compilation to customize it for the device that the user is running it on. So again, I don't need to know too much about this, but worth being aware of it. Okay. We then have our native C++ libraries. So many core components are built from native code that require native libraries written in C and C++. And if you need to, you can actually write some of those components yourself. Again, remember, it's open source. You can swap in, you can swap out some of these components. So if you need to write a specific one yourself that is relevant to your specific app, you could actually do that in native C and C++. Okay. Some of these are exposed as a Java framework APIs. So again, if you are, just to highlight that specific one there, our OpenGL. Right, if you need to do some kind of fancy graphics, and if you're looking at writing a game with 2D and 3D graphics, that's the particular element of the framework that you would be working with. So if necessary, you could actually write some elements yourself to enhance whatever you need to do. Okay, most of the time you won't have to, but in certain situations, especially if you're looking at writing some kind of a game that would have 2D, 3D elements in it, you might need to kind of customize something there yourself. Okay. We then have what we kind of focus on specifically as the developers. We have the Java API framework. So again, you can see, as I said, what it's made up of. We'll talk about these in later slides. Content providers. We have the view system. So again, a view, basically all those widgets, all the everything related to the UI. We have all our different managers. Then see them here. Right, our activity manager, and we'll talk about what activities are specifically in more detail later on. Location, if you're looking for location awareness, look, all the different resources. So that's all the elements that essentially that the user sees on a screen. Even talking about your telephony, your notifications, a couple more other ones in there as well. All these different managers, and so you as a developer would work directly with these APIs to build your app. So a huge part of Android development is understanding and being aware of what APIs are available to you and how to use them. Okay, location would be a great example there. That in the past, the location, and we will cover this in later sections possibly. In the past, location was there was a lot of boilerplate code. There was a lot of checks and I suppose things that the developer would have to focus on. Very simple. What's the best signal? Is it Wi-Fi? Is it network? Is it GPS? In the latest version of the APIs, a lot of that is looked after by a thing called the Fuse Location Provider. So that's taken away a lot of that extra overhead and kind of shifting the burden, shifting the workload back into those APIs. So it's part of the developer's job, I suppose, to be aware of the changes. First of all, what API is there, how to use it, and then the changes in those APIs through the different versions. Okay, so if we look specifically at some of the points we're making there, they're basically the building blocks for Android apps. They encapsulate lower level components and services, and we have all the different ones there that we're highlighting. There's our view system to build an app's UI, including lists, grids, text boxes, buttons, and even an embeddable web browser. We have a resource manager. which provides access to non-code resources such as localized strings, graphics, and layout files. Colors will be in there as well. Even if you wanted to have some audio and video, that would kind of fall under that heading as well. But everything would refer to them as a resource. We have our notification manager. There we have it just highlighting there. Enables all apps to display custom alerts in the status bar. So the same way you would get a notification that you've just received a new email via Gmail or whatever, you can write your own notifications as well, and that would all be looked after within the notification manager. So you then, as the developer, would have to become familiar with the notification manager API. Last view there, we have our activity manager, which manages the life cycle of apps and provides a common navigation backstack, and we will focus on that life cycle in this section here, just near the end of the slides. And then finally, our content providers, and we will focus on those a little bit now later on as well, enables apps to access data from other apps, e.g. Contacts app, or to share their own data. So the content providers, are a very nice way to share information, share data between apps. And we talked that there's other issues about security and about principle of least privilege. But to get around that, content providers are quite useful. Okay, and so we'll talk about those in due course. We also then have our at the top of the layer are the system apps, and these are basically the apps that the user uses. Okay, so we have a set of core apps for email, SMS messaging, calendars, internet browsing, contacts, etc. We refer to those as our native apps. Okay, these apps have no special status among the apps the user chooses to install. So whether it's a third-party app, whether it's a built-in native core app, the operating system doesn't differentiate between them. Okay, these are apps for users, and they provide capabilities that the developers can access. So just a final point to note there, a third-party app can become the user's default web browser, SMS messenger, or even the default keyboard, right? But some exceptions do apply, right? Such as the system settings apps. You can't really change the settings app. Most of the other ones you can. Okay, again, because this is open source and because the core, the native apps have no special status, as we've mentioned there, versus any other apps that the user wants to install. Okay, so the user, if you were building your own SMS messenger, your own messenger app, the user could decide to set that as the default app with very minimal kind of setup. Okay. So just to recap there, look at it all again from the bottom up. We have our Linux kernel, our HAL, we have our native libraries, Android runtime, and then where we work with most of the time as developers with the system apps and then the Java API framework. So as I said, a huge part of Android development is just being aware of the Java API framework and all the classes that are in there to help you solve the particular problem that you want to solve. Okay. Now, let's have a look at some of the Android application components. Okay, so to begin with, it's kind of the main one there, the one that the user will actually install, is the application itself. Can be written using Kotlin, Java and C++ languages, right? The Android SDK tool compiles code along with any data and resources files into an APK. So that's like your .exe that you have on a Windows machine, which is an Android package, which is an archive file with a .apk suffix. Okay, one APK file contains all the contents of an Android app and is the file that Android powered devices use to install the app. So this is what, when the user goes to install your app from the Play Store, that's what actually gets downloaded onto the device, and that's what gets installed. And what it's actually made up of is generally what we have here in this little graphic. So we have our manifest file. We won't go into too much detail, but for the moment, just kind of be aware that the manifest file is like the metadata about your app. So we'd have things like we have it just highlighted there, kind of the permissions maybe that your app has. So can it access the internet, can it access location, things like that. The different components. So does it have, it would have to list off all the different activities. Again, we'll talk about activities in a minute. So all those, any activity that you have inside your app would have to be listed in there. Also things like the version of your app, version number, which would tie back to the Play Store again, an individual package name, which ties in with actually hooking into some of the Google Play services, all the features. Getting down to some of the specifics, we have a kind of an assets folder, which would be all the different asset files that are associated with your with your app. We would have the meta-inf signatures, which would, again, maybe if you had Google Maps, you'd have a Google Map key tied to that there, kind of embedded in the APK. Your individual libraries that you might be using, the actual bytecode itself of all the different classes, and the compiled code that we'll be running are different resources, which will be the kind of the flat raw resources, like your images, any little graphics you have in there, maybe your colors, kind of any text, any strings that you would have been developed, any kind of widgets, UI elements that would be displayed on your app. And then finally there's those compiled resources in a resource.arsc file. Okay, so that now look, the user never sees any of this stuff. This is all bundled up inside that single APK file, which is what the user would download from the Play Store and install on the device. From the developer's point of view, when you are running your and building your app in Android Studio, if you actually keep an eye down in the bottom bar of the window as it builds, you'll see installing APK on your emulator or on your actual device. And that is a single file that you can find. And if you need to, you could actually email that file to someone else. And if they had an Android device and they opened it through Gmail, the device would pick up that it is an Android app you're trying to install and would ask you if you want to install it. So it's a very nice way if you need to share your app, or if you need to install your app on another device that's not your own device, you could simply email it. And we would have covered that in previous sections as well. Just to continue on, so to talk a little bit about the security model, okay? So each app lives in its own security sandbox, protected by a range of security features, okay? It's assigned a unique Linux user ID, so the system sets permissions for all the files in an app so that only the user ID assigned to that app can access them. Each app is a process with its own virtual machine, its own VM, so an app's code runs in isolation from other apps, and that has its kind of pros and cons, okay? Just the final point there on that the app is started when any of its components need to be executed, and the app is shut down when it's no longer needed, or when the system must recover memory for other apps. Now, there's a very important point here. Because each app has its own process and runs with its own virtual machine, when it's shut down, that is destroyed, and so the process is destroyed. So if and when the user launches your app again, so for argument's sake, maybe your app was paused while the user was taking a call, and then the user returned back to your app, and we'll talk about that in the life cycle now in a minute. But when your app would return back to, shall we say, the foreground and back to the app that the user is currently using, that may be a new process. So you as a developer have to be very aware of, was the user working with data, or did data need to be saved? Because it isn't just automatically backed up, because of that fact that it could be destroyed because the process is destroyed. So you need to ensure that your data would be, as I say, temporarily backed up in temporary storage, so that when the app comes back, the data is loaded back up. Very simple example, maybe the user was filling in a form and they had a name and an address and a phone number. You as a user would expect those fields to still be there when the app returned, but that doesn't happen by itself. You as a developer have to build that in because of this particular security model that's in place, okay? We've also got this notion of principle of least privilege. So each app by default has access only to the components that it requires to do its work and no more. This creates a secure environment in which an app cannot access parts of the system for which it is not given permission, and that those permissions are very, very important. However, there are ways for an app to share data with other apps and for an app to access system services. An app can request permission to access device data, such as the user's contacts, the SMS messages, and then the mountable storage, which might be on your SD card, the camera, Bluetooth, etc. The user has to explicitly grant these permissions. So when you are, if you've ever noticed it, and I suppose something to think about yourself as well, whenever you are installing an app, an Android app on your device, do you actually read the permissions and read what the app is looking to access? Because once you install that app and you grant those permissions, it does have access. So if the app is looking for your access to your contacts, if it's looking access to your SMS messages, when you say OK and say install, that app has direct access to all that information. So when you are writing your own app, if it's sitting on top of that and you need other extra permissions like location, like the camera, whatever, you have to, that's not granted by default. You have to explicitly ask in your app for access to those particular elements, like the camera, like again Bluetooth, like location or whatever. Okay, so permissions are a big part of any complex app that uses some of those sensors, some of those devices, elements, components of the hardware elements of an Android app. Okay, so to talk a little bit about the Android components themselves, okay, so app components are the essential building blocks of an Android app. Each component is an entry point through which the system or a user can enter the app, and each type serves a distinct purpose and has a distinct life cycle that defines how the component is created and destroyed. So we'll have a look. There's 4 main ones over here. We have our activities, which we'll kind of focus on in some detail. We have our services, which are things that kind of run in the background. We have our content providers, which are again ways of sharing data between apps. And then we have our broadcast receivers, which kind of ties in with the notifications. So if there are components that you would build into your app to listen for these notifications and then respond to those notifications in a certain manner. Okay, so to look at another graphic that kind of gives you a little bit of detail of what they all are. So these are kind of our main Android components. So if we look at the activities there, we'll go into these in a little bit more detail, but just to focus on them initially. We have our activities. So an activity represents a single screen with the user interface. In short, activities perform actions on the screen. Again, we go into those now in a lot more detail because these form a huge part of any Android app. We have our services. It's a component that runs in the background to perform long-running operations, so possibly downloading some audios, even some video file from the internet. We have our broadcast receivers. So they simply respond to broadcast messages from other applications or from the system. So again, notifications would be a very common kind of example of those broadcast messages. And then you write your broadcast receiver to respond to that notification. We have our content providers. So a content provider component supplies data from one application to others on request. And then finally there we have additional components. They don't fall under the kind of the main components, but they do make up your apps. So these are additional components which will be used in the construction of the above mentioned entity. So we have other elements that would be used to work with activities, services, broadcast receivers, and finally their content providers. Okay. So just to continue on there. So if you have a look at activities, okay, so an activity is the entry point for interacting with the user. It represents a single screen with the user interface. Activities work together to form a cohesive user experience. So an email app might have one activity that shows a list of new emails, another activity to compose an email, and yet another activity for reading emails. So from our point of view, every screen that you want to build, that you want to have in your app, is an activity, and that activity is a class which will control the screen itself, the UI elements, and also tie back to kind of data in the background itself. Okay, so to begin with, we might have some quite basic screens with some basic widgets, or we could actually progress onto some quite complex apps. And as you can see there in the example, we're using Gmail as a nice example there. So we have our initial kind of a list, which would be one activity, just kind of listing a summary of all this, the emails that we have in one activity. We might have another activity that allows you to go in and view them individually and look at more detail. Okay, so you kind of, when you're deciding on the type of app you want to build, you're probably better off, and we would have covered this in the design section as well, you're probably better off just kind of sketching out how you want your activities to look, how you want your screens to look, and then once you've decided on a nice layout, you can then go and build the activities, which will be and control the screens that the user sees. Okay, let's talk a little bit more about the activities. Right, although the activities work together to form a cohesive user experience, each one is independent of the others, and that's why the life cycle becomes so important. If permitted, a different app can start an activity in another app, okay? And a little example there, a camera app can start the activity in the email app that composes new mail to allow the user to share a picture. So we have all these, when we talk about an application can be a single activity, can be a kind of multi-activity app, okay, but each activity has its own life cycle, and again we will talk about that in a couple of slides, okay. Just to talk a little bit about the life cycle itself, okay. To navigate transitions between stages of the activity life cycle, the activity class provides a core set of 6 callbacks. We have, and there they are here at the moment. So we have our on create. Oh, sorry, I'll give you a better color there. Give you some red for that one. Highlight it a little bit better for you. Okay, so we have our on create, on start, on resume, on pause, on stop, and on destroy. The only one that's required, and that comes by default when we create one, is our on create function, our on create method. All the others are optional and are only needed to be implemented as necessary when you as a developer require that particular callback to be kicked off within the life cycle of the application, okay. So the system invokes each of these callbacks as an activity enters a new state. So if we follow it through here, to begin with, you can see it here. So we have, to begin with, the user would launch the activity, so they'd hit the actual your little launcher icon on your home screen. The first method that gets called is your on create. So whatever code you have in there will be executed, and when you've gone through the wizards and you add a new activity, you get that supplied by default, plus you get the small setup code that inflates the layout and then binds the layout to the particular activity. So at the very minimum, you are required to have this on create, okay. All the rest are options. So by default, if we just had the on create, right, the default on start and on resume in the superclass activity would be executed, and then the activity is in its running state. Now, if, and this is sometimes can be hard to get your head around, if another activity comes in the foreground, now that other activity can be another screen within your app or can be another actual separate app. So going back to the little example we gave, if the user is using your app, so your activity is running, and then a phone call comes in, so that other activity would be actually the phone app taking precedence over your app. So your app, right, would then go into on pause. But saying that, if the user was in your initial home screen app, the activity should I say, and then the user clicks on a button to take you to maybe a report screen or a kind of a list screen, then that activity, that list or that report, whatever other activity, other screen within your app comes into the foreground. So your initial home activity is paused, and it continues then to go through that life cycle where we have our on pause, and user returns to activity, back to on resume. So most of the time, 90% of the time, I say, your activity or your app and your activities within your app are cycling through this on pause, on resume cycle, okay. We've got the other use cases that if your activity happens to be stopped, so on stop would be called, right, and then it would get restarted again. So depending on all the different use cases that you might have, so if it's stopped, okay, we say take the phone call as an example, your app is stopped, right, but the app with higher priority needs memory. So the phone, the Android operating system realized you need to be kept on, the call is of higher priority, so your app gets killed off, so the process is killed, so you potentially lose any data, and then you're back into the on create again. Whereas if the activity is only stopped, right, and then the user navigates back to that activity, it's restarted, okay. So you as a developer just need to be aware of the full kind of life cycle and all the different methods that can be triggered depending on the particular use case that your app is kind of going through. It's only after on destroy is called that your whole activity will be shut down and kind of removed from memory. Okay, so but most of the time, just the main point to note is most of the time you will work with on create, possibly on resume, possibly on pause. Okay, I suppose another example there, if you're connecting to the internet and you want to make sure that your data is most up to date, you might decide to put it in the on resume, right? Because if you happen to put it in on create, that will only ever be called again if the process is killed. So if you want to make sure that code is called every time the user returns back to your that particular activity, that particular screen, possibly a list of data, you would put that in your on resume. But if you only want it ever to be executed the once on startup, essentially, you can place it in the on create. Okay, so there's quite a lot kind of to know about with that life cycle. But as a kind of a starting point, most of the apps we'll be working on, you will only ever need to use it on create. It's only when your apps start becoming quite complex and maybe working with remote services, that's when you need to be more aware of the other methods that are available to you to ensure that your app runs correctly. Okay. Other than that, I think that kind of wraps that up. So we've just the main references there on our developer docs. So you can get most of the information there about the components and activities and all your content providers and all the rest of it. So other than that, thanks for listening and goodbye.
Hello everyone, and welcome to this kind of short video to introduce this new case study, donation or donation X. Okay, now we will cover it in more detail in theory in the lecture material, but just to kind of run through that first lab that I would have asked you to cover in that kind of that recap section. So basically what the app is this fictitious run for president by Homer Simpson. So we have this option here to donate to his fund either with PayPal or direct, and we can pick a value from 1 to 1,000 and then we can donate. Okay, and then that donation is then listed or stored temporarily in memory, which can be viewed on another screen or another activity. So for argument's sake, if we go and we donate PayPal 1,000, we can see there, you saw the total. We keep track of a total as well there. Okay, and maybe we do another one direct and we can just spin it through there, saying again 994, donate, see it totals up. Or we can actually change it here and we can select an amount from there. So again, we just go back to PayPal again and we'll donate. So we've 3 donations. So then I can navigate to the report screen and then I see my 3 donations listed in the report screen. Now again, admittedly this is very basic at the moment, so all we're displaying is a placeholder for an image. We have the amount and in the type of donation that was made. Okay, and likewise we can go back to a donation screen and make another donation. Now if you notice, this is the solution minus the exercises. If you can see there, we lose the total. So that's one of the little things I've asked you to do as an exercise, and the solution will be made available in the second lab. All right, but I suppose the main point to make here is, even though it's basic at the moment, this donation app will, as the weeks go by, bring in more and more features, and will have a kind of a pretty serious redesign in terms of the architecture of the app. It may be week 4, week 5, bringing in the MVVM architecture, and we will use that then going forward. So by the end of the module, this donation X app will have Google authentication, will be tied to Firebase, will be working with images, will be multi-user, so we can keep track of both your own donations and other users' donations. We will bring in some map features, there'll be location, so it'll be quite a sophisticated app by the end of it. But just to have a brief look at some of the code in this lab, if we open up our donate screen,
So again, one of the kind of the new additions now within Android Studio is that they've kind of gone full circle on this whole view binding approach. So what they do now is based on the name of your layout, and we will cover all this in the material in due course. But if you notice here, we have this activity donate binding class. Okay, so this is an auto-generated class which will allow you, the developer, to directly bind. First of all, inflate and then bind to any widgets that are available to you on that particular layout. And the approach that's taken is that, and the naming conventions that are taken is that it's the name of the layout and then binding appended to the end of it. So if we look at our layouts over in our project window here, we have an activity_donate.xml. That's our layout. What we automatically get then is an activity donate binding class, which we can inflate and which we can then bind to. So here in set content view, what you may have been used to in previous modules, that this would actually reference a layout to be r.layout. Whatever the case may be. So in this example, it would have been r.layout.activity_donate. But to do with dealing with kind of memory leaks and just better approach, really better design, the recommended approach now is that you bind to your widgets through the auto-generated binding layout. So that's the approach we'll be taking throughout this module, and with any new layouts that we bring in, we will, when it's the application and the project is rebuilt, we get this newly auto-generated layout. So what we do is, if you notice up here, we have the declaration here, just calling it donate layout. We then inflate it, and then we access then our particular widget. So here, look, here we are accessing the progress bar. There's the amount picker, and then down here, here's even our donate button. Okay, so it's all done through the object, the layout object that we have binded to through that activity donate binding in this particular example. Okay, if we look at the structure, the overall structure of the app, we have our couple of activities, donate and report, which we just kind of saw there in the little example. We have an adapter to allow us again to present and display our donations in that list format. So we use the adapter to kind of access the raw data and then display it nicely in that recycler view. We will be looking at kind of more advanced features down the line, but for the moment, excuse me, we'll be using the adapter quite a lot. Okay, we have our application object. And then in terms of the design, we have a similar approach to would have been covered in previous modules, previous kind of case studies, where we have an interface, the model itself, and then an implementation of that interface. So the lab would have required you to bring in those particular classes, implement it correctly, and then build it up and run it accordingly. Okay. Also, some of the layouts. So there's our donate layout, our report layout, and there's a card donation layout, which represents kind of each donation that's displayed in that particular list. We've also a couple of menus, excuse me, donate and report, which allows us at the moment to navigate between the different screens, the different activities. We will update this later on and bring in some quite nice navigation elements, a nav drawer being one of them. And then also in our values, we just have our colors, our strings, and then the particular themes. Okay. So if we just have a quick look at some of the code there to work back the way, we have our interface. So at the moment, just as three individual functions: a find all, a find by ID, and a create. And again, the create takes a donation, the find all returns a list of those donations, and a find by ID returns an individual donation based on the ID passed in. Okay, the implementation of that is in our mem store, so you can see it here. So underlying the kind of the raw data is a simple array list of donations, which is wrapped up in this donation mem store. So there we are, implementing or extending from that kind of donation store, implementing that interface, donation store. Okay, there's our find all, returning that list. There's our find by ID, just doing a quick search. I'm using the .find function of the array list. And here's our create, just assigning the updating the donation model. We'll have a quick look at that in a minute. And then adding a donation to that list of donations, right? In terms of the log, we're using a kind of a relatively new logging class, Timber. So again, we'll be using that throughout the module as well. And if we look at the model itself, very basic at the moment, just a simple ID, simple payment method and amount. But as the weeks go by, we will be modifying this model, adding fields to it to allow us to be able to store more information and allow us then to tie back to in one instance a Node web server for when we cover kind of working with APIs and working with cloud information, and then finally when we tie it to Firebase, so there'll be some modifications made along the way. In terms of the application object itself, not too much at the moment. Here we are, just one instance really, just an implementation of that, again, donation store interface, and here we are initializing it based on our donation mem store. So again, similar to previous kind of case studies, this will allow us to potentially swap out one implementation and swap in maybe a persistent implementation at some later point. So that's kind of stuff we could look at as well. In terms of again, we had our donate, we were quick looking at that. I suppose that one point to note is just the event handler down here, and we have our working with toasts, working with Timber. There we are. Okay, and the overall event handling, just ensuring that we do have some information and data been submitted, and then if we exceed a certain amount, so we have a kind of a maximum set, in this instance 10,000, but we could change that to whatever you wanted really. Okay, I don't think there's much else to look. I suppose the report, simple enough. Again, all we're doing is we're referencing our application object to get at the data. Here we have a reference to our, in this instance again, look, activity report binding. So this is the activity underscore report layout. This is the class auto generated to allow us to access any of the elements and the widgets on the report layout. And here we are just binding to the application object, and then just setting up our recycler view to how we want to display our information in our linear layout, and then the actual data itself tied to that donation adapter, where we just pass in all the particular donations been returned via the find all function from the donation store implementation, which is stored inside our application object. Okay, couple of just dealing with the menus, again, not too much. I'll just scroll down a bit for you there. So all we're handling here is how we can navigate back from the report screen back to the donate screen. So again, this would have been one of the parts of the lab as well. Again, very straightforward enough, just working with the menu item itself, and then if the item ID happens to match action underscore donate, we start the new activity using there's our start activity, passing in the intent and identifying the class that we want to return back to. Okay, as you will see for the first couple of versions of the lab, the data is quite tightly coupled with the UI, which again isn't the best approach to take. So that's why in week maybe 3, week 4, we're going to look at moving over to what is now the recommended approach, which is that MVVM, or the model view model. So there'll be a lot of refactoring done with this application over the coming weeks. Okay, but for the moment, this is all I was looking for you to cover, just to get you kind of back up to speed again, and bringing in and working with adapters, working with activities, working with your layouts, and a little bit on menus there as well. So we're kind of ticking all the boxes there for the kind of the introductory stuff that we would expect to see in a short recap of Android. Okay, so there are obviously a few little bugs in this version. The total being and keeping track of the total being a fairly obvious one. So that's something we will look at in the second lab, at the start of that second lab, and then you can continue on. Okay, so other than that, thanks for listening, and we'll see you all in the next section.